The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so today we're going to go on to section 7.5. Before we do that, are there any questions from yesterday's assignment?
Yes, I have two.
Okay, give me a second here to open up a WebAssign. And okay. Alrighty. All right, what do you got?
So it was number 12. It says perform the operation.
Which section?
Section 7.4 from yesterday.
7.4.
I thought I did it right, but my answer on paper was wrong, and so I had someone help me. But I don't understand how they got the answer. So it was t plus 5 over t minus 5.
Okay, hang on. I'm still waiting for this thing to. Which number was it?
Number 12 on 7.4.
Well, okay. I've got it up here so I can look at it. Perform the operation. So you've got t plus 5 over t minus 5 minus t minus 5 over t plus 5. Okay. Go ahead, you were saying, or you want me to just go ahead with it?
Yeah, just go ahead. I thought I did all my work right, but the answer that I got help with doesn't make sense. So I just wanted you to explain it, like walk through the problem.
You bet. Okay, so first of all, each denominator is factored as much as it can be, okay? So the least common denominator would be the quantity t minus 5 times the quantity t plus 5. Are you okay with that?
Yeah, that's what I got.
All right. So this is what I need to have after I build things up. So I'm going to multiply the first fraction by t plus 5 over t plus 5. Okay.
Mm-hmm. So
the denominator will be what it needs to be. The numerator, if I multiply these together, I get t squared plus 5t plus 5t plus 25. Okay? You all right with that?
Yeah.
Which, combining like terms, would be t squared plus 10t plus 25. Okay?
Okay. I think I screwed up with the 10t because I had I had t squared plus 25x minus t squared plus 25. I don't know what I did there.
Okay. Also, you wouldn't be using x, the variable's t.
Okay, that's one issue.
Okay, so are you all right with that? Ready to
Yeah.
go on? Okay, so the next step, over here, we're going to multiply by t minus 5 over t minus 5. So then we're going to get t squared minus 5t minus 5t plus 25, which is t squared minus 10t plus 25. Okay. You all right with that?
Mm-hmm.
Okay. So now I've got t squared plus 10t plus 25 minus the quantity t squared minus 10t plus 25 all over the least common denominator. All right.
Mm-hmm.
So then I've got t squared plus 10t plus 25 minus t squared minus times minus plus 10t minus 25 all over the LCD. Combining like terms, t squared and minus t squared cancels. 25 and minus 25 cancels. So I've got 20t over the LCD, which is t minus 5 times t plus 5. Now, there's no factor that's common to the numerator and the denominator. So this is going to be your final answer.
Okay. Yeah, I screwed up somewhere in the beginning, so
Okay.
that makes sense.
Any other questions you'd like to look at?
Yeah, and then my other one was 24 on
Same,
7.4.
same section?
Yeah.
Okay. So we've got g divided by g squared minus 4 plus 2 divided by 4 minus g squared. Okay, this is that situation where these are opposites of each other. So what I'm going to do is I'm going to multiply one of these by -1 over -1. And what that'll do is give me that, because if I multiply that together, 4 minus g squared times -1 becomes -4 plus g squared, which is g squared plus -4, which is g squared minus 4, because these two denominators are opposites of each other. So by multiplying one of the fractions by -1 over -1, I now have the same denominators. So now I've got g minus 2 over, and I'm going to factor that, g plus 2, g minus 2. Okay. This reduces down to 1 over 1, and I'm left with 1 over g plus 2. You all right with that, Shannon?
Yeah, I got, I followed the -1 part, how you explained it yesterday or whenever this was. And so for my final answer, I got g plus 2 over g squared minus 4. I didn't do the g minus 2 and yeah, I screwed up on the last part where you have the g minus 2 over g plus 2, g minus 2. I didn't do that part.
Sure, sure. Do you see why it's g minus 2? Because you're multiplying the numerator by -1.
Kinda. I thought it was g plus and then in parentheses -2 over
Okay.
g squared minus 4. That's what I did.
Sure, but that's the same thing as g minus 2.
That's true. Okay.
All righty. Anything else?
That was it for me. Thank you.
Okay. Anybody else before we go on?
Yeah, I have 2 questions on 7.4 as well.
Okay, hang on just a second. Let me pull up your problems. Okay, man. And you said 7.4?
Yeah.
Okay. All right, which ones?
17 and 34.
Okay, let's start with 17. Okay, so just perform the operation, simplify if possible. So we've got 8 divided by y squared minus 16 minus 7 divided by y squared minus y minus 12. So I'm going to rewrite each of these original fractions, factoring the denominators. So I get 8 over y plus 4, y minus 4, minus 7 over y minus 4y plus 3. Okay. Good to go with that? I'll take that as a yes.
Yeah.
All right. So the LCD, I'm going to have a y plus 4 times a y minus 4 times a y plus 3. So this is where I need to be. My first fraction, I need to multiply by y plus 3 over y plus 3. So my new numerator is 8y plus 24. My second fraction, I need to multiply by y plus 4 over y plus 4. So my new numerator is 7y plus 28. So far, so good?
Yeah, that's what I got.
Okay, so now I've got 8y plus 24 minus the quantity 7y plus 28 all over the LCD, which is 8y plus 24 minus 7y minus 28 all over the LCD, which is y minus 4 over y minus 4 times y plus 3 times y plus 4.
Now, that's what I actually put on mine, and it says that I'm wrong.
Well, you're not done.
Oh.
Because these reduce down to give you 1 over y plus 3 times y plus 4. Because it says simplify if possible, so you didn't simplify it.
Okay, I see.
Yeah. Others?
My other one was 34.
Okay. Part A or part B or both? Looks like both.
Both.
Okay, so part A, 2a plus 4 over 3 minus 9 over a plus 2. I can't factor either denominator any further than it already is. So the least common denominator is 3 times the quantity a plus 2. All right. So the first fraction, I need to multiply by a plus 2 times or over a plus 2. Okay. So my new numerator is going to be 2a squared plus 4a plus 4a plus 8, which combining like terms is going to be 2a squared plus 8a plus 8. Okay. So far, so good?
Yeah, that's what I had too.
Okay. Second fraction, I'm going to multiply by 3 over 3. So my new numerator is going to be 27. So now I have 2a squared plus 8a plus 8 minus 27 over the LCD. Combining like terms, 2a squared plus 8a minus 19, I think it is. Yeah. Minus 19 over 3 times a plus 2.
Okay, I see what I did wrong. I accidentally put 2a squared plus 4a instead of 8a on accident.
Yeah, I see that. Okay. We all right with that one?
Yep.
Okay, part B is 2a plus 4 over 3 times 9 over a plus 2. We're multiplying, so we don't need a common denominator. We're going to factor everything. So this, I could take out a greatest common factor of a 2 and have an a plus 2 left over. 3 down below, a plus 2. 9 would be what? 3 times 3, if you wanted to write it out that way. So then I can reduce out one of the 3's and the a plus 2, and I have 6 over 1, or just 6.
Okay, thank you.
That it for that one?
Yep, that's it.
Okay, anybody else? Anything from WebAssign before we go on? All righty, so we're going to go on to section 7.5, and 7.5 deals with what are called complex fractions. So first of all, let's look at what a complex fraction is versus a simple fraction. So we'll start with a simple fraction. So a simple fraction, 1/2, 3/4, x plus 2 over 7, x minus 8 over y plus 16. These are all simple fractions. There's only the one fraction. There are no additional fractions in the numerator and or the denominator. Now let's take a look at a complex fraction. 1/2 divided by 3/4. X over y plus 3 over 7. X over w plus y over z all over 4/3. These are all complex fractions in that you not only have the main fraction bar, but you have at least one other fraction in the numerator or the denominator of the bigger fraction. Okay, so simple fractions, complex fractions. What we're going to do, we're going to take complex fractions and change them into simple fractions. That will be our first big task. Once they are a simple fraction, then we'll go back and look, can we reduce or simplify that simple fraction even further? All right, now let's start off with something from like basic arithmetic. 2/3 divided by 3/4. This is a complex fraction. 2/3 divided by 3/4. I could rewrite that as 2/3 divided by 3/4, right? Okay, now, but dividing by a fraction is like multiplying by its reciprocal. So we get from here to there. Now I have multiplication of fractions. I look to see if I can pre-reduce anything out. I can't, so I multiply straight across and I get 8/9. So we've taken the complex fraction, converted it into a simple fraction. Any questions about that one? All right, here's another example. 9/4 divided by 7 over x. So we have a single fraction divided by a single fraction. This is 9/4 divided by 7 over x, which is 9/4 times x over 7. Again, there's nothing I can reduce out of there, so my final answer, 9x over 28. Any questions there? All right. Another example, negative x to the 4th over 30, all divided by 7x squared over 15. So again, I have a single fraction divided by a single fraction. So I've got that, which then becomes multiplying by the reciprocal. Okay. In this case, I can reduce ahead of time. 15 over 30 is 1 over 2. X to the 4th over x squared is x squared over a 1. So I now have what? Negative x squared on top and 2 times 7, 14 on the bottom. Any questions there? All right, now, suppose I have this situation. 1/2 plus 3/4 divided by 3/2 plus 1/4. You cannot rewrite this well. You can't. Okay, let me back up. You can do that, but you can't take this and take its reciprocal without it being a single fraction. Okay, so unless you're starting with a single fraction in the numerator and a single fraction in the denominator, you can't use that process ultimately that we've looked at here and here. So what do we do instead? There are two different methods described in the textbook. I'm going to use the second method because it's less work. If anybody wants to explore the other method, feel free to do that. But again, it takes longer. So what I'm going to do, I'm going to use the least common denominator method. What I'm going to do is identify all of the denominators in the little fractions in the numerator and the denominator. Okay. So what is the LCD of 2, 4, 2, and 4? It is just 4. Okay. Any questions about that? So now what I'm going to do is I'm going to multiply. Oops, that was what happened here. Okay. I'm going to multiply the complex fraction by the LCD over the LCD. Now, the reason I'm writing these ones is to remind you where those 4s are. In other words, the top 4 lines up there, the bottom 4 lines up there. Okay. So now we're going to distribute. Let me move this over here. So 1/2 times 4 is 2. Okay. Plus 3/4 times 4 over 1 is 3, which is 5. In the denominator, 3/2 times 4 is 6, plus 1/4 times 4 over 1 is 1. Any questions about what I did there? So again, I identified the least, or all the denominators, all the little denominators, found the LCD for all of them, multiplied the entire numerator by the LCD over the entire denominator by the LCD, and then simplified as far as I could. Any questions? All right, let's take a look at this example. 2 over x minus 1/3 all over 2/3 plus x over 5. So my denominators are x, 3, 3, and 5. My least common denominator would be 15x. Any question how I got the 15x? All right. So I'm going to multiply by 15x over 15x. Okay, here we go. 2 over x times 15x over 1. The x's would reduce out and we'd get 30. Minus 1/3 times 15x over 1. 15 over 3 is 5 over 1, so minus 5. Make this fraction bar a little smaller. So we've got 25 on top. Okay, in the denominator, 2/3 times 15x over 1. 15 over 3 is 5 over 1, so I've got 10x. Plus x over 5 times 15x over 1. 15 over 5 is 3, so I get 3x squared. And that is plus 3x squared. Okay. And I'm going to rewrite that 3x squared plus 10x. Now, can I do anything else with that? Let's see here. Oh, I made a mistake, didn't I? Right here, I didn't get rid of an x. So this would be 30 minus 5x. Okay. You all right with that? So let's see, can I simplify that any further? Well, I could factor a 5 out and get that, and factor an x out and get that, but that doesn't get me anything I can reduce out. So here's my final answer. Okay. Yeah, I need to be more careful with what I got rid of and what I didn't. That's one of the dangers of crossing things out. Got to be able to read what you crossed out. Okay. New problem. 10 over n minus n over 4 all over 8 divided by n. So the LCD would be 4n. Anybody have any questions about how I got that? Okay. So I'm going to multiply the numerator and the denominator by the LCD. (10 over n) times 4n over 1. The n's reduce out and I have 40. Minus n over 4 times 4n over 1. The 4's reduce out and I have minus n squared. In the denominator, 8 over n times 4n over 1. The n's reduce out and I have 32. Now, the numerator is the difference of, well, n squared is a square, but 40 isn't a square. So I can't factor the numerator. Consequently, I can't reduce anything. So there's the final answer. Questions about that one? Okay. 3/5 minus 2 over 2/5 minus 2. First of all, there's an implied 1 in the denominators of those two numbers. Okay. So the LCD of 5, 1, 5, and 1 would just be 5. Okay. So I'm going to take 3/5 times 5 over 1, which is 3. Minus 2 over 1 times 5 over 1, which is minus 10. So that's -7. Okay. Let's see here. In the denominator, 2/5 times 5 over 1 would be 2. And then minus 2 times 5 over 1 would be minus 10, which is -8. But negative divided by negative is positive, so our final answer is 7/8. Any questions there? All right. How about this one? 3/4 plus 1 over y all divided by 6/5 minus 1 over y. So the LCD would be what, 2 times 2 times 5 times y, or 4 times 5y, or 20y. Again, if I need to explain where I got the LCD, hail me down here and I'll go through that.
Yeah, can you explain that?
Okay, so let's take a look at each of the denominators. Okay, so 4 is 2 times 2, or 2 squared. Y is just y. 5 is just 5, and y is just y. Okay, you all right so far?
Mm-hmm.
Now the LCD is the product of the highest power of each different prime factor. So I've got a 2 squared, a 2, and a y. So there's your 4 times 5, or 20y.
Okay, that makes sense.
All right. I'm going to go ahead and erase that. You got this written down as much as you need there?
Yeah.
Okay. Just want to make sure I have room to write everything else out. So let's get rid of these. Oh, my bad. Okay. There we go. Okay. Now, I have 3/4 times 20y over 1. The 20 over 4 reduces to 5 over 1, so I have 15y. Okay. 1 over y times 20y over 1. The y is reduced, and I have plus 20. In the denominator, 6/5 times 20y over 1. 20 over 5 is 4 over 1, so I get 24y minus 1 over y times 20y over 1. The y's cancel and I get minus 20. Okay. Now, can I reduce this thing? Well, let's see. In the numerator, I could factor out a 5 and have 3y plus 4. In the denominator, I could factor out a 4 and have 6y minus 5. However, that doesn't get me anywhere, does it? Hang on just a second. So there's nothing I can reduce out. So I'll go back to this as my final answer. All righty. Any questions there? Let's take a look at this one. D plus 2 over 2 divided by D over 3 minus D over 4. Now I have a single fraction in the numerator, but I don't have a single fraction in the denominator. So I can't just go to that thing we looked at the very beginning. So again, I'm going to use the LCD. What's the LCD of 2, 3, and 4? It would be 12. Are you okay where I got the 12? I'll take that as a yes. Okay, so D plus 2 over 2 times 12 over 1. 12 over 2 is 6. So I end up with 6D plus 12. Okay. In the denominator, d over 3 times 12 over 1 reduces down to 4d. And then minus d over 4 times 12 over 1 reduces down to minus 3d, which is 6d plus 12 over d. Okay. Let's see here. I could factor a 6 out of the numerator, but that doesn't give me any common factors to reduce out. So I'll go back to that. Okay. Questions there? We good? Okay. Let's see here. All right. 1 divided by x minus 1 all over 1 minus 1 over x minus 1. Now, again, there's an implied 1 denominator on that 1. Okay. So my LCD is going to be what? 1 times x minus 1 or just x minus 1? Everybody okay with that? All right. This thing a little bit smaller. So we're going to multiply by x minus 1 over 1, x minus 1 over 1. In the numerator, 1 over x minus 1 times x minus 1 over 1, the x minus 1 is reduced down and I just get 1. In the denominator, I have 1 times x minus 1 over 1, which is x minus 1. And then minus 1 over x minus 1 times x minus 1 over 1, which becomes minus 1 more. So I get 1 over x minus 2. Questions there? We good? Okay. Let's see here. How about this one? 21 over 8g cubed divided by negative 35 over 16g to the 8th power. So this one is a single fraction over a single fraction. So if I want, I can do it this way. Oops. Okay, and then let's see that negative, let's put that up there with the numerator. And then I can go back and reduce. I can say 7 goes in here 3 times, 7 goes in here 5 times. 8 goes in here negative 2 times, 8 goes in there 1 time. G to the 8th over G to the 3rd is G to the 5th. And I have what? Negative 6 G to the 5th over 5. Be okay with that? Now, if you wanted, you could come back and find the LCD of those two and multiply the top and the bottom. But when it's a single fraction over a single fraction, it tends to be quicker to use this method. But you can only do it when it's a single fraction over a single fraction. Okay, so be careful with that. Let's see here. How about this one? 3 divided by AB squared plus 6 divided by A squared B all over 6 over A minus 9 over B squared. All right, so my least common denominator would be a squared b squared. Anybody having trouble seeing where I got that? Okay. So distributing 3 over ab squared times a squared b squared over 1. B squareds reduce out, a squared over a reduces out. We've got 3a. Six over a squared b times a squared b squared over 1. The a squareds reduce out, b squared over b is b, and we get plus 6b. Denominator. 6 over a times a squared b squared over 1. A squared over a is a, and we get ab cubed. Minus 9 over b squared times a squared b squared over 1. B squareds go away, and we have minus 9a squared. Well, let's see. I can factor a 3 out of the top and an a out of the bottom, which gets me nowhere. So that should be my final answer. Let's see here. I can find. Okay. What did I do? Oh, I know what I did. No, maybe not. Hang on. I have made a mistake. So let's see if I can find it. Okay. So a squared b squared. That would be 3ab. So 3a. Okay. They took out a 3. So what did they do? Somehow that's supposed to be a 6. Oh, I know what I did. I know what I did. Can't read my own chicken scratch. Right here, I said ab cubed, and it's not ab cubed because that's not a b. What is that? It's a 6. Ugh, I hate these 6s and b's, especially with my sloppy writing. So sorry about that. So that would be what? 6ab squared? Yeah. My 6s. Okay, what does that do for us? Well, so now in the denominator, I can take out a 3a, and I get 2b squared minus 3a. And I can now factor out a 3, so we get a plus 2b over, and I'm going to multiply that a back in, 2ab squared minus 3a squared. Okay, sorry about that. So once again, don't use sloppy writing like your instructor does, so that you don't get your b's and your 6s confused. And a's look like 9s, and 5s look like s's, and z's look like 2s. Okay. Anyway, so there you have it. Section 6. How about 7.6? Is this Monday? It sure seems like it. Anyway, take care. I'll be back at 1:15. Hopefully I'll be back in one piece. Who knows? Otherwise, we'll see you tomorrow, folks.